Property 7 deals with different formulae that we have in inverse trigonometry. So the first and most important formulas relate to tan inverse functions. So tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy if xy is less than 1. So tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy if xy is less than 1. And if xy is greater than 1, if xy is greater than 1, the formula is pi plus tan inverse of x plus y by 1 minus xy. These are two formulas regarding addition of two inverse tan functions. And tan inverse x minus tan inverse y is always equal to tan inverse of x minus y by 1 plus xy. This is for all x comma y. And all these three formulas are valid for positive values of x and y. So whatever formulas that we are dealing with are valid for positive x and y. And if x is negative, I use minus x formulas to get that minus outside, and then once the arguments have become positive, I'll apply these formulas. There are three formulas in total. Tan inverse of x plus tan inverse of y is tan inverse x plus y by 1 minus xy directly if xy is less than 1. Tan inverse x plus y by 1 minus xy plus pi if xy is greater than 1. And tan inverse x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy if this is valid for all xy which are positive. So you might be wondering why you have different formulas when xy is greater than 1 and xy is less than 1. So let us look at why this happens. Okay, this is not necessary for your JEE Mains. The derivations are important only when you go for advanced exams. So if you're interested, you can see the derivation, otherwise you can skip the derivation. We can understand these two formulas using the quadrant diagrams for tan inverse. First, let us try to derive the basic formula. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus xy. And let us see what this condition is. What happens if xy is equal to 1? Because when xy less than 1, you have a formula. When xy greater than 1, you have a formula. So something should be happening at the boundary, right? So let us see what it is. And let us try to see the logic corresponding to this formula. So first, let tan inverse x is equal to some angle alpha and tan inverse y is equal to some angle beta. We have assumed that both x and y are positive. Both x and y are positive. That means alpha is an acute angle, beta is also an acute angle. That is, alpha is in between 0 to pi by 2, beta is also in between 0 to pi by 2. Because a positive number is going inside tan inverse, a positive number is going inside tan inverse. The answer will be in the first quadrant. So this implies x is equal to tan alpha, y is equal to tan beta. Now, what is tan of alpha plus beta? The formula for tan of alpha plus beta is tan alpha plus tan beta, that is x plus y by 1 minus xy. So tan alpha plus beta is x plus y by 1 minus xy. So this implies, now if I apply tan inverse on both sides, tan inverse of tan alpha plus beta is equal to tan inverse of x plus y by 1 minus xy. Now tan inverse of tan, alpha is in between 0 and pi by 2, beta is also in between 0 and pi by 2. So what is the range of alpha plus beta? The first angle is some angle between 0 and 90 degrees. The second angle is also in between 0 and 90 degrees. So if you add these two, alpha plus beta can go from 0 to 180 degrees. So on the whole interval 0 to 180, tan inverse and tan do not cancel each other. We have seen that tan inverse of tan cancels each other as long as this angle is in the range of tan inverse, or this angle is in the restricted domain of tan. So what I say is, I'll cancel these two if alpha plus beta is less than pi by 2. That is, from 0 to pi, if alpha plus beta is in between 0 and 90 degrees. So if alpha plus beta is less than pi by 2, that is in between 0 and pi by 2, so you get alpha plus beta is equal to tan inverse of x plus y by 1 minus x. What is alpha and beta? Tan inverse x plus tan inverse y. So tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy if right now alpha plus beta, the sum of these two angles, is less than 90 degrees. Now what happens if alpha plus beta is more than 90 degrees? So if alpha plus beta is more than 90 degrees, directly these two cannot cancel each other. So I need to bring this into the range of tan inverse. So if alpha plus beta, for example, alpha plus beta is equal to 2 pi by 3. So you have tan inverse of tan 2 pi by 3. So the angle is in the second quadrant. So tan is negative. So if you draw the quadrant diagram for tan, plus minus plus minus. So tan 2 pi by 3 is negative. So to get an allied angle, you have to go to the fourth quadrant, right? So first what I do is, I'll do pi minus of 2 pi by 3, I get 60 degrees, and I'll take the negative of that, so that the angle goes into the range of tan inverse. So what I do is, if alpha plus beta is in between pi by 2 and pi, tan inverse of tan alpha plus beta can be written as tan of pi minus of alpha plus beta with a minus sign. That is alpha plus beta minus pi is equal to tan inverse of x plus y by 1 minus x. So now alpha plus beta minus pi. So alpha plus beta, 0 less than alpha plus beta is less than pi, but we are considering alpha plus beta to be in between pi by 2 and pi. So what happens to alpha plus beta minus pi? So this is in between minus pi by 2 and 0, which is in the range of tan inverse. Now these two are getting cancelled. So this implies now alpha plus beta is equal to pi plus tan inverse of whatever it is. So that's what you got the second formula. Now the question is, so how do you decide whether alpha plus beta is less than 90 degrees or greater than 90 degrees? What is the logic which determines whether the sum of these two is greater than 90 or less than 90? So this comes from the identities. So we have already seen that tan inverse of x plus cot inverse of x is equal to pi by 2. And cot inverse of x is nothing but tan inverse of 1 by x. So tan inverse of x plus tan inverse of its reciprocal. So if you have a number here and its reciprocal here, the sum will be exactly equal to pi by 2. That is, if you have x, if y is nothing but 1 by x, is according to this, if y is equal to 1 by x, if this number is 1 by this number, the sum will be exactly equal to pi by 2. So that means xy is equal to 1 is the condition which ensures that the sum is equal to pi by 2. Now if xy is less than 1, that means one of the numbers is less than the boundary condition. If x into y is equal to 1, so this number will be exactly equal to pi by 2. The sum will be exactly equal to pi by 2. If this number, if this product is less than 1, that means at least one of the number would have decreased or both numbers would have decreased. And as the number decreases, the corresponding angle decreases. So the sum also decreases. So if xy is less than 1, that simply means that the sum of these two is less than 90 degrees, where this formula works. If x into y is greater than 90 degrees, x into y is greater than 90 degrees, that means xy, tan inverse x plus tan inverse y is greater than 90 degrees, hence you get the second formula. So I hope you understand what is happening here, and I encourage you to get the formula for tan inverse x minus tan inverse y also. So I am not doing the derivation for that. You get the exact same type of derivation, and in the negative formula you won't be having these cases. You'll see that alpha minus beta always belongs to the range of tan inverse, so you don't need to get two different cases. So you need to remember these formulas very clearly. These are the most important formulas of your inverse trigonometry. Now let us look at some examples on this.